All right, guys. So our lesson today is the properties of magnets. So take note, I have highlighted the word properties because this is where we are beginning from. So what do you think is the meaning of properties in physics, or it is the meaning of property in physics? So whenever they are talking about properties in physics, or if you are asked to define what is meant by properties in physics, properties in physics means measurable changes that happen to a material, or measurable changes that we can observe with our eyes, um, relevant to a particular material. So the material that we are talking about today is magnets, and we want to talk in particular about properties of magnets. So in other words, we are talking about the changes that we can observe when we are using a magnet. All right, so that's our lesson today. So I've subdivided the lesson into origin, non-contact force, magnetic materials, magnetizing and demagnetizing, magnetism in technology. Okay, so let's look at the origin of magnets. Magnets come from a rock, and this rock is called lodestone, right? The rock has got parts of the rock are naturally magnetic. So, in other words, magnets are natural. They come from this rock called lodestone. It was discovered way back in time. Okay, now they say magnets are a non-contact force. What does it mean? It means that a magnet, for it to attract a magnetic material, it doesn't need to be in contact with it, but the magnetic material rather needs to enter into the magnetic field and then it gets attracted. That means that, take this to be a piece of magnet in red. This piece of magnet has got a magnetic field, okay, or in simpler terms, like a sphere of influence. So this magnetic field, it's actually a described field. You cannot see it with your own eyes. We cannot see a magnetic field, but we see the effects of a magnetic field, right? So a magnetic material, or anything that is made out of material which can be attracted by a magnet, as long as it exists inside the magnetic field, it will be attracted to the magnet. That is what they mean when they say a magnet is a non-contact force. Let's go on to talk about what are magnetic materials. Okay, so magnetic materials, it is anything that can be attracted by a magnet. Anything that can be attracted by a magnet is a magnetic material. So you can list iron, zinc, all those are magnetic materials. Now let's talk about magnetizing and demagnetizing. So iron, for example, gets magnetized when it is attached to the magnet. But iron will not continue being magnetized when you take it off the magnet. But there are some materials which continue to be magnetized even if they are removed from the magnet itself. Most alloys will continue, like steel. It will continue, it actually becomes a magnet as long as it has come into contact with the magnet. It will continue with the magnetism. So if you take a needle and you want to make it magnetic, you stroke it several times. Let's say this is a magnet. If you stroke a needle several times, then it becomes magnetic. Magnetized material can be demagnetized by heating, applying a high temperature, or by hitting with a hammer. So either you hammer them or you apply heat, then you will demagnetize a magnet. Magnetism has been used in technology. This is an ATM card, and this black strip of the ATM card is magnetic. What they have done to the ATM card is that, so let's say that is the the ATM card, and that strip, I colored it green on the board, but it's black here. So that strip has got a magnet. So there are tiny magnets here. If you want, you can take any ATM card and make some tiny iron filings and spread them there. They will stick because this part is magnetic. So what the banks do is that they put a pattern on this ATM card. So the magnet in this ATM card, this black part, has got a pattern, and that pattern is linked to your PIN number. Your PIN number is your name. So let's say your PIN number is 2424. Okay, so this pattern is linked to 2424, right? But however, 2424 is known by you, and this pattern will recognize 2424. So the decoding can be done by a computer at the bank. So that's magnetism in technology. Now let's go on to look at the North Pole and the South Pole of a magnet. So every magnet has got a North Pole and a South Pole. So let us say the red part is the South Pole and the blue part is the North Pole. Okay, so the same poles will repel, but different poles will attract. So I want you to go on and pause the video and try to give your reasons why you think different poles will attract. What makes different poles to attract, and what makes same poles to repel? Okay, the explanation that is behind the attraction and the repulsion is this. The magnetic field behaves similar to the electric field, right? So if you take a battery, if you take two batteries, and this is the negative and this is the positive, if you connect the positive to the positive like that, positive to the positive, electricity will not flow. But if you connect batteries, the negative to the positive, electricity will flow. Even when you connect wires here and you put a bulb there, that bulb will come on. But if you connect wires on this one and you put a bulb, this bulb will never go on. So there is something that you need to notice on these poles. There is no conflict in the direction of movement, right? There is no conflict. At this stage of grade 8, I want you to check this as direction of flow, right? So the direction of flow here is the same. If this could be batteries, then there is no conflict of direction of flow. But if the two poles were facing each other, they would have behaved like that connection of batteries, and there will be conflict of direction of flow. So basically this is about it on the properties of magnets. And I just want to encourage you as scientists to go and dig more information, find out more on the topic of magnetism, and we will continue.